Today we get to talk about numerical patterns and rules. So we're going to be identifying patterns. This is something that is not new. We've been identifying patterns for a while. A lot of times it's with shapes or different things that you notice. We're looking at numerical patterns. So how numbers are increasing. Are we increasing by adding the same thing each time? Are we increasing by multiplying by the same number each time? That's what we're going to be working on today. We're going to organize those patterns within tables. And we call these patterns rules, okay? So a numerical pattern shows a rule used on an ordered set of numbers. Tables can be drawn two different ways. You see the first one, this is horizontal. And then the other version, what would I call that one? Vertical. So you can see tables written in both different ways. They're the same thing, but notice something. Notice that X is always first. So in a horizontal table, X is first on top. In a vertical table, X is first because we read left to right. So it's on the left. Okay, my table that we're going to look at right here, we're going to talk about the left side. Now we'll go back to the right in a little bit. Okay, where we identify the two different types of tables we'll see. What type of table is this? Horizontal or vertical? Horizontal. Is it going sideways? Are my X's and Y's going to the right? That's vertical. They're going down. So I'm listing them down. So this is considered a vertical table. Okay. So on the left side, we typically will call this the input. Anybody ever heard of input-output tables? Yeah. Okay. So the input is typically my X value. My output is typically the Y value.
Is it in the middle? Is it the middle put?
In the middle is typically not going to be shown. Look at my tables over here. Do you see a middle row or a middle column? No, it's typically not shown. That's why we call it like the magic column. Okay, it's the invisible column. Magical things happen there because that's where the rule takes place. That is where the math is happening to get from the X to the Y. It's just not what we see all the time, okay? So this is typically not shown. This is the rule that we're going to be talking about today. We typically don't show the rule in the table. Now, something you need to know, if numbers are increasing, so if numbers increase from X to Y, so that means if my number is like a 1 and it goes up to like a 4 to the Y, they're increasing from X to Y, or they're increasing from X to Y in a horizontal table, okay? Then the rule or the pattern is adding or multiplying. Does that make sense to everybody? If it's increasing, then I am either adding to it or I am multiplying to it to get those bigger numbers. If numbers decrease, then what do you think the rule or the pattern is? It's subtracting or dividing. Because that's how I make numbers smaller. Okay. Now again, I have these two different types of tables. I have my horizontal, I have my vertical. You need to know that numbers in the table do not have to be in order. Sometimes we skip around. Sometimes it doesn't go one. It doesn't always go 1, 2, 3, 4, 5. Sometimes you'll see like 1, 3, 7, and it just gives you some of the values, okay? We are going to use at least 4 pairs to find the pattern when we practice today. Okay, we're going to use at least 4 pairs. So we see some tables at the bottom. We have 2 different types. We have a vertical, we have horizontal, On the first one, it says we need to find the rule. So when we find the rule, we are trying to figure out what are we doing to the x to get to the y. If we think that we're subtracting how much to get from 5 to 3?
2.
If we think we're subtracting 2, we better try to make sure it works for the others before we say it's our rule. Would it work from 8 to 6,
Yes.
11 to 9,
Yes.
14 to 12?
Yes.
Okay, so we can assume and we can know and prove that our rule is -2. See, this is my invisible column here. We typically don't show this in a table, but there is something magical happening there. It's math. Magical math is happening. Okay, to get from 8 to 6, I'm subtracting 2. 11 minus 2 is 9. 14 minus 2 is 12. 17 minus 2 is 15. And 20 minus 2 is 18. Please also notice I am not going up by ones here. Notice how they skip counted. What are they skip counting by, actually? 3s. So it's 5 and then 3 more is 8. So it's going to show me if I were to take these x, y numbers and list them as like an ordered pair for graphing, if I were to put those points on a graph, it would actually increase really nicely because my x's increased by 3s. All of my dots would be evenly spaced out. Okay, let's look at the horizontal table. This time it says complete the table. My rule is times 4. So that means that I'm going to take 5 times 4 to get my y, which would be 20. Okay, well now I'm given the y on this one. So what do you think I need to do to figure out the x, Addie?
What times what equals 32?
Right, so if I know that my rule is times 4, I can work backwards and use the inverse operation and do 32 divided by 4, which gives me x, which is 8. The next one is 44 for the y. So 44 divided by 4 would be 11. Oh, now I'm given the x again. So I've got to do 14 times 4, which is 56. I'm given the x again, which is 17. So 17 times 4 is 68. This time I'm given the y. So I got to do the inverse. 80 divided by 4 is 20. 22 times 4 is 88.
20 times
4. My rule is times 4.
20 times 2 equals 3. Oh, wait, no, never mind.
Okay.
That's 60.
And then 40 times 4 is 160. 4 times 4 is 16. So if it's 40 times 4, it's 160. Okay, this time I'm given a complete horizontal table, but I need to find the rule. So again, I'm going from x to y. What am I doing to get from 64 to 8 or 48 to 6? I'm going from a bigger number to a smaller number. If the numbers decrease, then I'm either subtracting or dividing. I'm dividing by 8. Remember, x to y. X to y. 64 divided by 8 is 8. 48 divided by 8 is 6. 40 divided by 8 is 5. 24 divided by 8 is 3. Do y'all see why it's dividing 8, not multiplying? Okay. We always go x to y, top to bottom, or left to right, depending on the type of table that we have. Look at the next page of notes. So remember expressions. We can sometimes put an expression in for the rule. Okay, so that's the rule. We're taking it a step further and we're just naming it an expression now. Okay, so we're, instead of calling it a rule, we're calling it an expression. We just practiced several different types of rules or expressions. Same concept here. Okay, so I have 3, 5, 7, 9. My rule or my magic column means that I'm adding 23 to n. Sometimes you will see tables like this. I'm given input numbers and I'm looking for the output is sometimes what we call it. If I'm given an n number, I'm just looking for the totals. So what I'm going to do is I'm going to apply my rule. 23 plus n would look like this. 23 plus 3, because it tells me that n is 3 here. This is like the paper that you did yesterday. We're just putting it in tables instead. Okay, so That means that my answer would be 26. This time, 23 plus n, my n is 5. So my answer is 28. 23 plus n, if n is 7, then my answer is 30. And then the last one, 23 plus n, which is 9, my answer should be 32. So I'm still using expressions. It just, instead of telling me, solve the expression for n is 2. I have a whole bunch of different n's I can use because remember it's a variable and variables can change depending on what it is. In a table I have a lot of different numbers that I could use for n. So I'm showing what the total is for all of those different numbers. Okay, here's some more examples. For this one, notice that I did not include that in-between column. I just showed the beginning to the answer. Up here, I do have the rule, or my expression. So for this one, it's going to be D plus 30. So what will I actually write for my answer here?
33.
33. Notice how I just took away the magic column. I no longer have that middle column. I'm just applying the rule. Okay? 12 plus 30 is 42, and 16 plus 30 is 46. Okay, now remember when I have something like this, what does it mean? Multiply. So it means 5 times G. So 5 times 6 is 30. 5 times 9 is 45. 5 times 12 is 60. 5 times 15 is 75. Notice there's a pattern. Some of us notice that pattern. We're increasing by 15 each time in my second column. Okay, on 3, I'm doing m divided by 10. So if I want to divide 350 by 10, that would be 35. 240 divided by 10 is 24. 120 divided by 10 is 12. Do you want to try 4 and 5 and then check them?
Yes.
Okay, try them maybe on your own and then check with your table and then we'll check whole group. Okay, so when you subtract 13, you end up with 52, and then when you subtract 13 from your last y value, you get 13. All you're doing is subtracting. You're following the rule or that expression. And number 5, the expression given to me is 12x, which means 12 times x. All of my x values are 5, 7, 10, and 20. The first one's done for me, so I do 5 times 12, which is 60. 7 times 12 is 84. 10 times 12 is 120, and 20 times 12 is 240. Very good.